Hello. Alright, so the purpose of this video is to basically show you how to find the vertex of a parabola, specifically from its vertex form. Okay, so the vertex of a parabola is a point at which the parabola makes its sharpest turn. So it could be a minimum value, so you know something that looks like this. This could be a minimum value, or it could also be a maximum value. So something that looks like this. This would be a maximum value. Okay. The vertex form of a parabola is given here. So f of x equals this a in front. So recall we've gone over transformations recently. So one way you can think of that a being multiplied in the front, that could be a vertical stretch or vertical compression. If it's negative, what you're going to realize is that would be a reflection across the x-axis. Okay. In comparison to its parent function, which would be x squared, right? So this h here, what that h will do is it's basically going to horizontally shift the parent function, and this k on the outside will vertically shift that parent function x squared. Okay. So that's one way you can think about how to find this vertex. But let's try to look at some examples so you can kind of see how this works. Okay. So let's say we want to identify the vertex of the given parabolas that you see here. Okay. So we have f of x here equals -3 times x minus 5 squared plus 6. Okay. So what we know from this is basically the vertex form, right, is f of x equals is basically a times x minus h squared plus k. So basically the vertex is just this here, right? So h comma k, which is our vertex. Maybe I'll write this here so you guys can kind of see that. So vertex, so this would be h comma k, and this would be 5 comma 6. That's how you identify your vertex. Okay. So one way to also think this in context, right? If you have your function x squared, right? So if your function x squared looks like this, basically this parabola will go under some interesting transformations. First, it's going to be reflected, let's see, across the x-axis because it's negative, right? And then, let's see, it's going to be shifted 5 units to the right, yeah? And then it's also going to be shifted 6 units up. This 3 in the front says it's going to be vertically stretched, so it's going to get skinnier. So it's going to look something like this, and that would be our vertex here. So it goes from 0, 0, and it goes up to 5 comma 6. That's in general what's happening, if that makes sense. Okay. Let's go ahead and look at another example here. Okay, so we have f of x equals 4 times x plus 7 squared minus 5. Okay. So one way that you can do this, so if you just think of it, if you want to write in this form, you could put 4 times x, and the plus is same thing as subtracting two minuses, right? So x minus, and we have -7. That's one way you can write this, minus 5. Okay, so based on our vertex form, right? So this here and this here just matches up. So in order to identify the vertex of this parabola, h comma k in this case would be -7 comma -5. Okay, and that's it. That's basically how you would do that. If you want to think about this in the context of transformations, generally what you do, right, you can think of it as your parent function, which is x squared. Let's see, the plus 7 here says that this graph is basically going to be shifted 7 units to the left, right? So it's going to be here. The minus 5 says that this graph is going to be shifted 5 units down. So this comes down here, right? And then, what happens here is that this will be vertically stretched by a factor of 4. So your parabola, if you were to graph it in decimals or something, it basically goes from here to here. If this was 0, 0, this would be -7, -5. Okay, so that's what that would kind of look like. Let's go ahead and look at another example here. So f of x equals x plus 3 squared plus 11. So same idea. So if you want to think about this in the context of what I showed you at transformations, that's fine. You can do it that way. If you want to just manipulate the formula in order to find your vertex, then you can do that as well, right? So basically this right here is h, this right here is k. So your vertex, h comma k in this case would be -3 comma 11. In other words, from the parent function, you're shifting it 3 units to the left and then 11 units up. Last problem here. What I see for this, right, this would be h and this would be k. So your vertex would be 10 comma -4 if you would just read it from basically the vertex form. Yeah. Another way that you can think of it, right? So if this was your parent function, which was x squared, right? This is x squared. Generally, what's happening is you're going to reflect it across the x-axis because there's a minus sign in front here. You're going to shift it 10 units to the right. You're going to shift it 4 units down. And then you're going to vertically stretch it by a factor of 5, so this thing gets skinnier. Maybe something like that. That's not the best drawing, but I think you get the point. This is 0, 0, and then 10 units to the right, 4 units down. 10 comma -4. So that's how you would identify the vertex. Okay. And in general, that's basically it for this video. Please let me know if you have any questions on this. All right, thank you. Bye.